In this video, we'll be having a look at simple linear regression. This is also known as a trend line. One of the concepts we'll be using, you may recall it if you've had a statistics course, R squared, which is known as the coefficient of determination. Well, let's go and plunge in. First thing I'd like you to do is install an add-in. Go over here to File, left click on it, and way at the bottom you'll see Options. Now when you have this appear, you'll want to go down close to the bottom where you have add-ins and click on that. And where it says here Manage Excel Add-ins, just click the Go at this time. Now you notice I have Analysis Tool Pack checked. That's what you'll want for this particular video. So I'll click OK. Now if you by chance are following the step-by-step on perhaps another screen, after installing it, if you click on the data, you will find way over to the right Data Analysis, and that has something we'll be using in just a couple of minutes. Now I'm going to be showing you two ways to do linear regression, and each way has its advantages. Just a very quick way of doing it that also gives you a nice visual look at this is to take the original table and do a scatter plot. So let's select study time and grade. So I'll go to Insert here. The charts, I'm going to click here so I can select them, and what I want is just a scatter plot. So I'll click on that, and notice you can like move around to see what these other things look like without actually committing to any of them, but again, a scatter plot will be nice here. Now let's put some real-world interpretation on this, even though I just made up this example. Suppose we have some students who are preparing for a test, and most students, the night before a test or the day before, we'll study a certain amount of time before last-minute preparation. And let's suppose that their last day study time ranges from 0 hours up to 6 hours. Well, although there won't be a perfect relationship, we expect that for the most part, people who study more are likely to do well. There are, of course, exceptions. So here in column B, I've listed the grade that those students got. And all this scatter plot does is it shows those combinations. So let's look at the 6 here. This, our x-axis, has study time from 0 on up to 6 hours. And then here, grades from 0 on up to maximum 100. So at 6 hours, notice this point would correspond to a student getting a little under 80. That would be our 6,76. Another student got a 93 and another got 100, based on these last three entries here, last 3 rows. Now, if you tried to draw a straight line through these, you couldn't do it. But just visually speaking, it does appear that there's an approximately linear relationship. The more study time, the higher the result, with just a fair amount of variation thrown in. Well, every straight line can be described by an equation of the form y equals mx plus b, and I'm going to show you how to add the equation for this very simply. So here you should see these 3 icons. If you don't see them, you'll want to just click somewhere within your graph. So I'll click on that. As I told you, linear regression is also known as a trend line. So let's come down here and check on the trend line, and you can see you've got a straight line approximation to those points. We're not going to go over the statistical theory here, but there are certain equations that can be used to determine the line that best fits the data. Now click on the arrow key to the right and go down to More Options. You may not see this right now. There are these 3 different panels, and if you're somewhere else among those 3, make sure you click on the one that looks like a histogram, because it'll have what I want you to check next. Display equation on chart, That's kind of nice. So you see the equation of the line is y equals approximately 7.9x plus 51.1 or 2. All right, so that's the equation of that approximating line. Another thing we can do is, while we're at the more options, is you could also click on display the r² value. Well, let's drag that down a bit. Kind of small, the font that they use. It's r² equals 0.7549, called the coefficient of determination. Well, here's what it means in practical terms. When we look at our original data, we see here that the study time does have some predictive value of the grade. More studying, generally speaking, higher grades. What r² means, first we'll put it in terms of a percent. 0.75 would be like 75%. Let's just round there for the moment. So r² is approximately 75%. What it means is 75% of the variation in these grades is explained by study time. So it's not explaining it 100%, but it's explaining 75% of the variation in the grade. You know, you can imagine what else might explain the grade. Well, you know, it could be maybe aptitude in the subject. Some people are better at subjects than others. So this would be saying that 25% of that variation is explained by something other than study time. I often have students ask me what's a good value of r², and it actually is very subject dependent. A chemist, for instance, would probably be looking for a larger value of r². In medicine, this might be pretty good in a lot of contexts. If we were studying human behavior, such as in sociology, a much lower r² value would probably be acceptable. So I can't really answer that question. You kind of have to look at it from a disciplinary level. All right, so that very simple technique that I just showed you shows you what the line looks like, gives you the equation of the line, gives you some measure of how effective this approximation is. And furthermore, we can use the equation now to make predictions. So suppose we had study time of, just make something up, how about 3.5 hours? And suppose based on this model we wanted to predict the grade. So I'll start with an equal sign because I'm going to do a formula. I want to look at this equation we got. Now y is the grade, x is the study time. So our grade would equal, let's type the 7.9. Now just to make it quick right now, I'll approximate. I probably would not do that if I wanted better accuracy. But let's say it's 7.9 times, and then we put in the study time there, the 3.5. So it's 7.9 times the study time, and then it says plus the 51, and let's just round that to 0.2, and then hit equals. So this is saying someone who studies 3.5 hours, on average, we'd expect a grade of about 79. Okay, so you can see how valuable having an accurate regression equation can be. Now, I said I'd show you a second method, and this is real quick, and it gives us a lot of extra information. So if you've installed that add-in, click on your data, come over here to data analysis, and I happen to have done a regression before this, so I'm still on regression, but there's all kinds of options. Click on regression, say OK, and I did another regression earlier today, so let me clear these things out of it and start from scratch. Input y range. The y is what you're trying to predict. We're trying to predict the grade. What I'm going to do is first click in this box and then select column B, including the label at the top, the word grade. Click in the cell next, and X is what you're using to make the prediction. We're using study time. Include the word study time. Because I did include the words at the top, they're known as labels, I want to click on this label box here. And I recommend you always include your labels. Output options is just where you want to put things. You could put them on a new workbook or whatever, but I'm just going to put them somewhere on this page. So I'm going to click within that box for output range, and I'll put it right here. It'll be beneath everything else, and click the OK there. All right, we have a lot of data. In order to read it, I'm going to go and enlarge a large column here. Now this is an elementary look, so we're not going to talk about all these things, but let's just get at some of the most important things. You remember when we did it by the other method, we got about 75% for R squared? Well, notice R squared here. It's the same value, except for they're given to a different number of places. Observations, that's how many data points you were using. It's easy to see that there were 21 here. I'm as inclined to make silly mistakes as the next person. Occasionally I'll get something that doesn't make sense, and I'll realize by looking at observations that, oh, I didn't select the whole thing. How did I do that? Maybe I left out a couple. So that's a good check to get used to looking at. And the last thing here would be down where we have what are known as the coefficients. And in an equation, the coefficients are the numerical values, such as you see here in this equation, the line. What I'd like you to see is we've got the same values. You know how we had 7.9 in front of the x? Well, that's the 7.9. Remember, x was the number of hours studied. And then for intercept, also known as the y-intercept, that's the 51. So the general rule of thumb is intercept will be the number that doesn't have the variable attached to it, and then study time would be essentially the coefficient that has a variable after it, like the 7.9x. Now, these various values I'll be talking about in a different video where I go into reading, an extensive reading of the output. I'm just going to finish up by saying why this second method using the add-in is important. Because after all, at this point at least, since we've ignored this other stuff, it seems to have just told us the same stuff. Well, you can also use multiple things to predict a value. So here all I used was study time. Suppose in addition to study time, we had some measure of attendance, where we probably would expect that students who attended more often scored well. So we could perhaps also have another column here for attendance, and then we might want to use both study time and attendance to predict the grade. That's known as multiple regression. It'll be covered in a different video, but with multiple regression, you really can't do a simple plot like this, and you'll need to use the regression add-in. Okay, I hope this proves to be helpful to you.